Welcome all participants. Program will be started in next 4 minutes. Please invite your friends. Please share the link in WhatsApp groups and invite them. Within 4 minutes, we're going to start the program. Welcome all participants. Session will be started in a minute. Please invite your friends. Within a minute, we are going to start the program. Yes, hello all. Welcome to day 2 program. So today we are going to see different kind of projects using OpenCV, and some of them are our own projects. The ultimate target of exhibiting these projects is to create some awareness on what kind of things we can do. With simple code, seriously can make wonders. Okay, so there are plenty of resources are available for computer vision. So we'll be sharing some resources also. Okay, so let me introduce about AIMERS one more time. I already explained you yesterday. AIMER is Artificial Intelligence Medical and Engineering Researchers Society. The society is a non-profit organization. The purpose of this society is to do research on medical related activities related to medical field. For example, ophthalmology. If you take ophthalmology, we can start working on images related to eye, retina. So if you can find something innovative which can help the people, seriously, it will change the world, right? So we are here to do research on AI based, using AI on medical stuff. We have some institution members already who are engaged with us. They are NRI Institute of Technologies from Agiripalli. Second one is CMR Technical Campus, Hyderabad. Third institute, BVRIT Hyderabad Women's Engineering College. Fourth one, B.R. Siddhartha Engineering College, Vijayawada. And as of now, the fifth one is Narayana Engineering College, Gudur. As of now, these are the 5 institution members and few more medical institutions, as well as few medical hospitals, as well as medical professionals also in our group. So I request you to do some sort of research on medical domain. Plenty of people. Yesterday I gave you one particular problem. In every 1,000 births, in our country, 30 infants are dying within a year. They cannot express. 1 year baby cannot express why, what kind of pain he is undergoing, right? If you can do something by observing the data from the neurons or from the nerves, we can collect some data, okay, from spine cord also. If you can get that data and if you can analyze the data, then seriously we can change plenty of things in medical field. If you can, your smartwatches can detect the heartbeat, right? If your smartwatch can also predict heart attacks, or you see, it's not about just 1 or 2 things. If it can detect some abnormalities of your heart, then we can prevent plenty of deaths. Of course, we cannot stop death, but we can postpone it. We cannot stop death, okay, but we can postpone it. So if you can make such type of devices which can detect the heart rate and heart strokes or brain stroke or something abnormal stuff, so we can protect plenty of lives, okay? Just think in that way also. Around 90% of the participants today are from students' background. You have very creative brain. Students means you're learning something, right? If you don't implement the things what you learn, it's seriously useless. The things what you have learned, you have to implement it. Okay, well, we'll discuss many things these days. In coming days, we are going to discuss plenty of like this, okay? No issues, we'll start with computer vision today. So over to you, Vishwanath. So let me allow him, okay. Now you can start sharing your screen, Vishwanath. You're allowed to share your screen.
Okay, sir. So I hope I'm very well audible.
Yes, you're audible.
Okay, thank you, sir. All right. So coming from yesterday, we've seen some, functions in OpenCV to manipulate the images. Okay, to crop them, to draw lines. Okay, to apply different filters, blurs, even canny, right? Today we're going to do the same, but we're going to use some of the machine learning. Okay, let me start sharing my screen. 1 second. Okay, so I hope you can see my screen right now. All right, so today we're going to use some of the some machine learning, okay, to detect these faces. So there are some machine learning models that are already pre-built. Okay, they were trained with lots and lots of images to detect faces. They've been given with lots of images with true positives, false negatives, like this is a face and this is not a face, and combining all of those, they've made pre-built models in the form of XML files. Let me show them to you actually. So this is OpenCV's GitHub repository. These are called HAR cascades. Okay, hope you can see this here. Okay, so these are called HAR cascades. So what are these HAR cascades? There are different types of HAR cascades for different object identifications. Okay, for eye, okay, and see, for cat face, for for face from front, and for full body, license plate, etc., etc. So they've already trained these machine learning models and stored those data in the form of an XML file, so that we now can make use of it. See, we are using this OpenCV to do different sorts of applications. I mean, to apply it for different scenarios. Okay, we don't need to necessarily know about how the whole machine learning training is done. I mean, if you're interested, you can know that. But for this, for solely this purpose, that whole process is kind of unnecessary, right? So there is this one XML file, har cascade frontal face default. So this is that XML file. So this is that XML file which was pre-trained, okay, to detect faces. So now what we're going to do is we're going to import this into OpenCV. So OpenCV has given us a way to import these models into our code. Okay, we'll import these and we'll get some images with some faces in those images, and we'll try to detect those images. Okay, first, if we can detect the faces in those images, then we can do next steps, right? We'll just take baby steps in developing projects. Okay, so we'll just get into coding. So basically, the first and important thing is that we import the CV2 module, that is OpenCV. All right, and then we're going to have to import the model, the machine learning model. So this is that XML file. I've got this right here. Okay, this is the har cascade frontal face default. So let me actually increase the font size for you. I hope this, I think they should be fine. So I've got the XML file here in my resources folder itself. We're going to use that. First, we're going to have to create an object for that, to hold the model. So I'll just name my variable, object as face cascade, and we'll use the cv2.cascade classifier function. Okay, so now you can give any type of XML file which is a pre-built machine learning model. So I'll just specify the path here. I'll just copy the path from here. So this is our model. So pretty easy stuff, right? Until now, so we've done just nothing. We just imported the CV2 module, and we use the CV2's cascade classifier. Okay, so for this function, you can give any type of model you want. So for now, we're only detecting front-facing faces in images. So we're going to use that for now. So we've got our model ready. And what is the next thing we have to do? We need an image, right? We'll just take the yesterday's image, this image, and I've got a few other images also with two people in them. Okay, so we've got these three images here. So we'll start off with the single one, right? With one person. So we'll take the image as IMG, and if you remember yesterday, to read an image into OpenCV, we use the IMRead function, which is going to specify the path, resources / the file name is portrait.jpg. So yeah, there you go. One important thing here with this, with this function or with this classifier is that it can detect faces only in grayscale images, that is black and white images. So what we have to do, we have to convert this image into grayscale. So we've already done it yesterday, and we'll do it again tomorrow. Sorry, today. So we'll just name our variable gray, and we'll use the cv2.cvt color. We'll take the image and change it to BGR to gray. So this will just turn the image to grayscale. Now our image is ready to be, recognized by the classifier. right? So we're gonna take all the faces. So, 1 second, right? So how we do that is by using the not CV2, our object, our face cascade object. It has this function called detect multi-scale. So what this will do is this will detect the actual faces in the images. Okay, this will return all the coordinates where the face is located. Okay, in the image, it will return the exact pixels from starting to ending where this image is where this face is located in the image. So we need a way to save them into a variable. So we'll just save it to this faces variable. So now what is this faces? We'll just see what's in the faces. Okay. We'll run this now. One second, we got a error. Oh, sorry, we didn't give the image. So we need to give the image here. Yeah. So let's just see what parameters this function takes. Okay. So this function takes image, okay, scale factor, and min neighbors. So these are the three arguments that you need to give. So this is the image that which image you want to give. So we'll just select as gray, and then the scale factor. Let's just select 1.1 for now, and minimum neighbors. So I'll take 4. So what are these two parameters? This is a little bit hard to explain because I just show you with two more cases with these parameters. I'll just take two different parameters again, and you'll understand. So this is like a threshold value, okay, of how how this model recognize faces. Okay, if we put it, I mean, you just have to like what should I say? You have to experiment with different values and find a suitable one for you. Okay. So let's just run this for now. So you can see it has detected one face in this from this location to this location, right? So what we'll do is, okay, we'll just draw a rectangle around the face and then show the image, okay, so that we know that the face is detected. Okay, if we just show the image right now, cv2.im show. Face detect. We'll just call it face detect. Okay, now if I run this, sorry, I need to give a wait key so that it will stay. It was capital K. Yeah, that's why it's important to have these editors which will auto complete the code for you. You won't like always remember the capital letters and small letters in there. So right now you can see that nothing is showing up. Like the face has been detected, but where? For this now we'll use different OpenCV functions here. So for all of these 4 coordinates, x, y, width, and height in faces, what we'll do is we'll draw a rectangle around it. Okay, we'll use the cv2 dot rectangle. We'll draw it on the image where from x comma y to x plus width comma y plus height, and we need to specify the color. Let's say I want to draw a red rectangle, so that would be 0, 0, and 255. If you want a blue triangle, blue rectangle, you can specify 255, 0, 0, or whatever you want, and the thickness we'll just put it to 2 or 3 something. Now we drew the rectangle around the face. Now we can show the image. So now you can see the face is detected here, and we drew a rectangle around here. Okay. So you can see like this is a very, very simple code here. Like literally did nothing here. Apart from importing this XML file, you just read the image, okay, turned it into grayscale for the because the image because the model can only detect faces in grayscale images, and then detected the faces, took the coordinates of each face, and you applied a rectangle. You drew a rectangle around each face, and then just showed the image, right? So coming to this part where you have the these two variables. So let's see what happens if I put it as 0. Okay, minimum neighbors. So now you can see like there are lots and lots of boxes drawn. It is unnecessarily detecting the faces that don't even exist. See, this is not a face, but still it detected. Okay, so these parameters just define how the sensitivity of the model. Okay, so we'll try with 1. Let's see what happens now. So the number has reduced, but there are lots of false positives like this hand one. This one is unnecessary because this one is already detected, and we are showing it again. Okay, let's try 2 now. So this kind of works fine. It's just basically the same with the 4, which I used at the first. Okay, so it is up to you. You have to experiment with the different values and know what your sweet spot is. We'll try with a different image. Let's take this image now. As you can see, both faces are detected. Now we'll use 2 here. Let's see what happens. Now I can see this one is also detected as an image, I mean as a face. So like I told before, you have to play around with different types of values to know which is the perfect value for you. Okay, again you can see there. If we use 1 here, the threshold is very low and it's showing the same thing. If we use 4 here, so now we get the correct detected faces. And finally we'll try with this one. In this image the lighting is a little bit brighter. Okay, the lighting is on the back side, so I believe it should be a little bit difficult to detect the face than this one. So we'll try with that. All right, it detected both the faces. So let's try with a different threshold value. I mean, different minimum neighbors. Try with 0 here. You can see a lot of false positives are given. See, this is not a face, this is not a face, and this is definitely not a face. Okay, like that. You just have to play around with different values that you want and find what is the correct value for you. So there you have it. That is how you can detect different faces in OpenCV using this cascade classifier. Okay, the same thing you can do with video. You can do with real-time video also. Uh, you know, I think, I mean, I would say that detecting things in video, I mean, doing things in video in OpenCV is not even hard at all. If you know how to manipulate an image, you can easily do so with video also. But for now, I don't have a video shot here, and to show through my front camera, I'm not in a situation to show the front camera right now. So that is why I'm not showing. So a video is basically a bunch of frames, right? So instead of putting this here, you will all just put this whole code in a infinite while loop or for loop, okay, until the all the frames in the video finishes, right? So yeah, Satish sir. Uh,
Yeah, thank you very much, Mr. Vishwanath. So not just about OpenCV, there are many more libraries you have to explore. One of my favorite libraries is Yolo, YOLO. So where we are working on a kind of test robot, we use this library called Yolo, one of the fantastic libraries. Right now, I think version 5 is running. Just search with the word called YOLO, YOLO. Okay. Some more libraries directly from Google, one of the topmost libraries, TensorFlow. That also can be used for computer vision. So there are plenty of libraries out there. I'll send you the list of libraries in our WhatsApp groups. So these groups, whatever you have joined, all those groups will be forever. All the upcoming workshops from AIMERS related to medical as well as related to AI will be posted in our groups. Some of you are asking about participation certificate. Okay, we'll work on that. We have to discuss with our committee about the participation certificates. We'll let you know about the participation certificate. But let me tell you, just viewing some video and getting certificate will never give any kind of benefit to you. Viewing this video, and if you implement it, if you can work on some good project related to CV, computer vision, that adds a lot of advantage for your career. 90% are students who are watching today. So my strong recommendation to students, don't run after certificates. Certificates are just for memory purpose. Anyways, we'll discuss about the participation certificates with our committee members. We'll let you know. So we are going to see some more projects now. Mr. Vishnu is from Coimbatore. He's a third year student, I think. Mr. Vishnu, please unmute yourself.
Yes, sir. I'm third year.
Third year student. When he was in second year, he developed a simple project. Most of you like cricket, right? Obviously, most of the guys, especially guys, will like cricket. So if umpire in that particular place in the ground, if he could not able to track, if he could not able to figure out whether that particular batsman is out or not, then he'll ask for third umpire decision. This Vishnu Kumar, when he was in second year, he developed a simple application like third umpire, which can tell whether that particular batsman is out or not. Okay, he's going to demonstrate that particular application now. Over to you, Vishnu.
Thank you, sir.
You can introduce yourself and you can share your data, your project.
Thank you, sir. This is me, Vishnu Kumar. I'm doing third year BTech IT in Government College of Technology, Coimbatore, which is in Tamil Nadu.
Yes, you can share your screen and you can start working on it. Just
Sir, is my
explain.
screen visible?
Yes, your screen is visible.
Okay, sir. And this is my project, which can detect the run out of a batsman. And it also tells whether the batsman is out or not. So I shall show the outputs of two videos. So we can see here that we can it shows the select the stump. I'm going to select the stump manually. So this blue color lines selects the stump. It selects only the stump. And next it shows select the crease. So now I'm going to select the crease and it's running. Status of the wicket, it's rolling. Now we can see that the crease is detected here, white color. When the bat enters the crease, it detects in green color. When the keeper hits the stump, it is also detected and it shows not out because bat reaches the crease first. So this is an example for not out. Now I'm going to show run out. So Again, I'm going to select the stump and then crease. So when I press enter, it detects both the stump and the crease. So we can see that the crease is detected. The ball is coming here and is going to hit the stump. So when it hits, the detection, the changes are detected and it shows out because the ball reaches the stump first. Now I'm going to explain the code. I have imported CV2 and NumPy. The basic is these two libraries. I'm capturing the video here in this line, and then next I'm reading the frames. Here I'm going to detect the motion of the bat and the motion of the stump. The stump is going to change when the actually the stump is stationary, but when the bowler or any other player going to hit the stump means it changes. So we can see here that a small deflection and it is also detected. So I'm using here motion detection. And next, when the batsman enters the crease, he is also in motion, so we can also detect that. So that I'm using two frames here, bat 1 frame and bat 2 frame. From bat 1, we can see the difference between the first frame and the second frame. If there is any changes between the frames, we can detect, or else both the frames will be same. So next, I have selected here, I have selected only the stumps. This is done using this code, these lines. And next, I'm getting the basic information about the frame, height and the width for further process. Next, I'm getting the crease. I have detected a crease like that. So we are getting the crease. Cropped image for bat. I have selected the particular region to detect the changes only in that particular region, not the full frame. I'm not going to detect the changes in this full frame. I'm going to see the changes only in this particular frame. So that I'm cropping the image. Next, processing bat image. Vishnu sir told that the detection is only done using will be better when it is in grayscale. So I'm changing BGR to gray and applying Canny filters. So after this, the bat images and the stump images are being processed. Next, finding the contours of the bat, finding contours. I'm going to see the changes between the first frame and the second frame, the bat image 1 and the bat image 2. We shall see the definition in a finding contours. So difference in images. I'm getting the difference between the first frame and the second frame. If there is any motion, we can detect the contours. So I'm seeing for the changes in the bat, and at the same time I'm seeing the changes in the stump. And this is a basic logic, whether the bat reaches the crease first or the ball reaches the stump first. So this logic used to display the result. So here I have detected the crease. When the bat reaches the crease, it is detected. Here I have selected the stump. So this is a simple code which detects the run out of the batsman. Thank you, sir. Thank you, everyone.
Yeah, very good, Vishnu. It's very happy to see you again after a long time. So we are making a Google form now. Please be hold on for attendance sake. Next participant, next Hema will be taking care of the next presentation. Guys, please be hold on. I'll be sharing a form for participation certificate. Okay. So don't leave this YouTube video. That particular Google form will be alive only for 20 minutes. Okay. I'll share you within few seconds. I'll share you. Once Hema presentation is completed, I'll share with you. Okay. Yes, Hema, over to you.
Yes, sir. Sir, is my screen is visible, sir?
Yes, it's visible.
Yes. So, good evening to all.
Can you increase the font size? In YouTube, we cannot zoom in most of the mobiles.
Yeah, sure.
Set 32. No, don't reset. Just click on 32, choose OK. Yeah, choose OK directly.
Sir, is it?
Okay, apply it once, font size not increased. Choose apply. Are you changing in editor?
No, sir.
Yeah, in go to settings.
Yeah, edit.
In editor. Editor font is 32.
Yes, sir. It is in font only.
Click on general, code editing. Select left side code editing. General.
General.
I think that's a font only you have to increase. Vishwanath, just check once.
Yes, sir. I think the font has increased.
But it's not looking like that. Okay,
No,
choose
just close the.
Mm.
Okay. Just go to settings and yeah, in editor font. Yeah, it's the same thing.
It is in editor only.
Okay, increase to the 60. Let's check once. Choose apply. Okay, it's just changing in the comment section, but not in the code section.
Yes, sir.
Okay.
Okay, we'll check. Just continue with that.
Okay. Sir. Can I continue, sir?
Yeah, please continue.
I'm Hema Duvuru from Indian Servers. Now today I'm going to explain a simple project called body pose estimation. Basically, body pose estimation is one of the computer vision technique to track the movements of a person or an object. This is usually performed by finding the location of the key points for the given objects. Based on these key points, we can compare various movements and postures. So this pose estimation can be used as the base model for many applications like fitness, yoga, and dance applications. So yesterday, Mr. Vishwanath gave an introduction to OpenCV. There he took an image and he resized and cropped and created a new image from the actual image. Today I'm going to take an video and do some functions on it. So let me run this project. So the output will give you the clear sense. So if you observe here, these lines of code detects the movements, body poses. Uh, so let's move on to the code part. So don't worry about the lines of code. Just understand the functions and what is happening in that functions and how they work. So just understand that. Okay. Here, first import the OpenCV and then import media pipe. We know what is OpenCV. So now I briefly explain you the what is media pipe. So basically, a media pipe is a framework, uh, and it is mainly used for building multimodal audio, video, or any time series data. And and then import the time. So I imported time here because uh, now I need to calculate the frames per second. Okay, that is nothing but FPS. So these drawing utils supports the thickness and the color. So by using these drawing utils, you can you can draw the landmarks and the connection lines. If you remember that output, and the
వస్తా
and the pose is a ML solution for high fidelity body pose tracking, and it contains the 33 3D landmarks and the background segmentation mark on the whole body of whole body from RGB video frames. So and the main thing is this media pipe only is only able to support a single person pose estimation. If you need to if you need multiple persons pose estimation, then we take the open pose and pose net instead of media pipe. So now here here by using the OpenCV, I'm reading the frames from the video named video 2, and that frames are converted from BGR to RGB. By default, the OpenCV supports the BGR, so I convert the color as BGR to RGB image. And by using the media pipe, the media pipe will draw the landmarks on the entire processed frames, and finally we will get the output with landmarks. So these are the landmarks like this. So it draw the connections and it point out the body pose. So if you you can see, if you observe here in this terminal, you can see the list of pose landmarks here. If you observe here, here a list of pose landmarks in this terminal section. Each landmark consists of X, Y, Z. Okay, X and Y are the landmark coordinates, and they represents the width and height respectively. And these are normalized to 0 to 1. If you observe each and every landmark, for X and Y, it is in the range of 0 to 1 only, because they are normalized. So, and the Z represents the width, and the visibility, it is a value that indicating the probability of the landmark being visible in the image. And this visibility is also in the range of 0 to 1. And this is the simple project. And by using this project, we can this is the base model to if you see this output, it if you add some lines of code, then we can estimate how many steps, the same steps are there in that video. We can do some operations on that. So thank you, Sai Satish sir.
Yeah, thank you, Hema. Thank you very much. So most of you know about somebody, if somebody copies a music, there are plenty of YouTube algorithms are there which can detect from where he had copied, right? But how about if somebody copies a dance movement? So if these kind of softwares are used to figure out how many times this particular person copied these many steps from so and so song, if you can make such type of projects also, it will be helpful. Of course, it's not helpful for medical domain, but based upon this media pipe library and human body pose estimation, there was one guy around 4 months back. I read his project. If somebody is in some trouble, based upon his body pose, it will detect with the help of CCTV cameras. I read that particular article 4 months back. Even for small babies also, at night, nobody can see 24 hours, 365 days. Nobody can observe them, right? For 24 hours, 365 days, small babies. So if these kind of applications are embedded in the CCTV cameras, then they will detect if some harm force is there, it will alert us. Okay, come up with such type of innovative things. There are plenty of things out there where you can do research and you can work on. And we have plenty of problem statements from medical domain. Plenty of problem statements, not just one or two. If you're good in AI, we're happy to work with you. We are very happy to work with you. Okay. So thank you participants for all the participants for joining in this program. In the description of this video, we have pasted one link. You cannot see it directly right now. You have to refresh the page, then only you can see. That link will be activated till 8/5. Please fill your details. We'll send you participation certificate within 3 or 4 days. Okay, it's not a hard copy, it's a soft copy. We'll share. All the upcoming programs we will post in our WhatsApp groups as well as in Telegram group. You can stay tuned in our Telegram as well as in our WhatsApp groups. Okay, thank you very much for joining in today's workshop on computer vision. We'll send you participation certificates. Just fill your data before 8/5 today. Thank you. Bye all. Refresh the page, then you can see the link. Otherwise, just reload the description of this video. Yes, I can see some responses. One already responded. That means link is working properly. So don't say link is not working. Okay, done.